Hello children, welcome back to the science video session. In this science video session, you are going to learn the lesson Universe and Space from Physics of Standard 7. Come, let's move on to the video session.
Unit 2 Universe and Space. Introduction. Starry night sky is a wonder which has fascinated humans from time immemorial. Our ancestors have observed and documented the objects seen in the night sky. The field of study of the universe is called astronomy. We note that there are billions and billions of stars in the universe, although only about 2000 or so are visible to naked eye. Have you ever think of the size of our universe? The universe is unimaginably and infinitely big. Universe is commonly defined as the totality of everything that exists or is known to exist. Even though the spatial size of the entire universe is still unknown, it is possible to measure the observable universe. The universe consists of galaxies, planets, stars, meteoroids, satellites, and all other forms of matter and energy. And it is a world of wonder. Let us move into this world of wonder to know more interesting facts about the place of residence of our solar system. Geocentric Theory. Sky is a wonder. Sun, moon, stars all appear to rise in the east and move towards the west, giving us an impression that all these objects are going around the earth. Just as in a moving bus, the distant mountains and trees appear to move backwards, perhaps really earth is spinning, and that is why sun, moon and stars appear to go around the earth. Does the earth revolve around the sun or the sun revolve around the earth? How do you know about it? When you look at the night sky, you can see a lot of twinkling objects, but a few of them differ from the others. They don't twinkle, and while the other stars hold a fixed pattern from night to night, these drift. They wander across the sky, moving against the backdrop of stars. These are called planets. Our ancestors observed this and they imagined a universe with the earth at the center, the stars in the distant background, and sun, moon, and the planets orbiting around us. Two observations supported the idea that the earth was center of the universe. First, from anywhere on the earth, the sun appears to revolve around the earth once in a day. While the moon and the planets have their own motions, they also appear to revolve around the earth about once per day. Even the celestial sphere studded with stars appears to rise and set in the evening and make one complete rotation in a year. Second, the earth seems to be unmoving from the perspective of an earthbound observer. It feels stationary. As civilization progressed, the early astronomer found two types of motions of celestial objects. Let us take the case of moon. On a daily basis, moon appears to rise in the east and set in the west. Thus, one can say that moon is going around the earth with a period of one day. But for a careful observer, it was clear that the moon was also exhibiting another motion. Suppose the moon is appearing in the sky today near the star Ashwini. Tomorrow we will observe that the moon is near the star Bharani, a star east of Ashwini. And the next day it will be near the star Kartigai, east of Bharani. After 27 days, moving little by little eastwards, the moon again stations itself near Ashwini. Thus, every day moon appears to move from east to west in one day, whereas it appears to go in a circle from west to east in the background of stars in about 27 days. These two motions were puzzling. Very soon, astronomers like Aryabhatta said that the earth is spinning in its axis. That is, the cause of apparent daily motion from east to west, whereas the eastward motion of moon in the celestial sphere with a period of about 27 days, we seen as the actual motion of the celestial objects. Thus, the geocentric model, that is description of the universe with spherical and spinning earth at the center and the sun, moon, stars and planets all orbits the earth emerged in various cultures. In Greece, this model was put forth by the Greek philosopher Plato and his disciple Aristotle in 6th century BC. It was standardized by a Greco Roman mathematician Ptolemy in the 2nd century AD. A similar model is seen in the Siddhantic astronomy in India, like Aryabhatyam of Aryabhatta. How moon exhibit phases. Astronomers in ancient times also observed certain facts. The Purananuru of Sangam literature, the poet Kalatalaya singing in appreciation of Cheraman Perinjeraladan says, on the day when the full moon appears, the sun and moon look at each other with their bright light. In the evening time, one spear hides behind the mountains. On the full moon day, when the sun is setting in the west, precisely at the same time, moon rises at the east. That is, both sun and moon are in opposite side. Likewise, when it is waning of moon, the moon is rises. When it is midnight and the waxing of moon rises during noon. From such observations and modeling, ancient astronomer could explain why we have waxing and waning of moon. What is meant by waning? Waning is nothing but a shrinking or decreasing in illumination. What is meant by waxing? It's growing or expanding in illumination. So it is probably easier to understand that waxing and waning of moon in order of new moon and full moon, and then how the first and third quarter moon appear, and then the phases in between. Sun is the source of light. Sunlight falls on the spherical earth, but only on the side facing sun. The opposite side of earth is without sunlight. As the earth spins day and night, follows as different parts of earth appear before the sun. That is, at all times one of earth is illuminated by sun and one of is in darkness. Likewise, at all times one of moon is illuminated by sun and the opposite side is shrouded in darkness. As shown in the diagram, when the moon is positioned between the earth and sun, notice all the illuminated part of moon is away from the earth. Hence we cannot see any part of the illuminated side of the moon. Only the dark side of the moon is towards the earth. When the moon is in this position, we have new moon. Now look at the moon when it is behind the earth. Now the portion of the moon illuminated by sun is totally towards earth. The dark side is away from the earth. This means the moon will appear to be round in the sky. This is full moon. When the sun, earth and moon are in 90-degree angle, how will the moon appear to a person on the surface of the earth? Now, if you look at the portion of moon facing earth, we will see half of it illuminated and half is dark side. Thus, the moon will appear as half moon. The half moon during the waxing period is called as first quarter, and the half moon during the waning period is called as third quarter. Once we understood those four key moon phases, the phases between them should be fairly easy to visualize. The word crescent refers to the phases where the moon is less than half illuminated. The word gibbous refers to phases where the moon is more than half illuminated. Waxing essentially means growing or expanding in illumination. and waning means shrinking or decreasing in illumination. Note also that these discoveries could be made with naked eye. You do not need telescope or any modern equipment. Epicycles. Moon going around the Earth with 27-day period nicely explained its motion. However, astronomers in ancient times faced problem in explaining the motion of their known five planets: Mercury, Venus, Mars, Jupiter, and Saturn. Moon in the background of stars moved every day eastward nicely. However, for example, if we were observing the motion of Mars from January, it would appear to move eastward in the background stars. That is, the position of Mars today will be near a star which is east of the star near which it was yesterday. However, on June 28, we will see a change. From that date, the Mars would appear to move west rather than its normal eastward motion. This reversal of direction of planet is called as retrograde motion. If we continue to observe on August 28, once again the Mars would appear to reverse the direction and again on its usual eastward motion in the celestial sphere. Usually, Jupiter is brighter than Mars. However, around the period of retrograde motion, the Mars was much bright than other times, even brighter than Jupiter. Other planets also exhibited number of puzzling behaviors. Venus and Mercury always appeared very close to Sun and hence never appeared in the midnight sky. The brightness of Jupiter also varied again when it exhibited retrograde motion. For example, in 2018, Jupiter reversed its direction of motion on March 9, 2018, and again resumed its normal eastward motion on July 11, 2018. The simple geocentric model where planets go around the Earth could not explain why the brightness of the planets changed and why they reversed their directions. Change in brightness and retrograde motion would be impossible if we assume that the planets were at the same distance at all times from the Earth. To explain the puzzling phenomena, astronomers in early times proposed a change in the simple geocentric model. This is called as Epicycle Model. Ptolemy in Greece, Aryabhatta in India, and others used the epicycle model to explain the motion of celestial objects. Their models were improved by generation of astronomers like Tycho and Nilakanta Somayaji. Although the model explained many phenomena, there were a number of mismatches. The model was becoming messy. Arrival of telescope. Telescope was invented by Hans Lippershey, but Galileo used it for studying the sky for the first time. The telescope showed more universe than visible to naked eye. With a simple telescope matching toy telescope of today, Galileo was able to see mountain on the moon, small dim stars invisible to naked eye, sunspots on the face of the sun. He was able to demonstrate that the Milky Way, an hazy bright patch in the sky, is nothing but thousands of stars huddled together. Jupiter had moons going around it, and Saturn had mysterious appendage which we know as rings. One of the most startling observations he made was related to telescope observation of Venus. This convinced him to accept the theory of the Polish astronomer Nicolaus Copernicus that it is not the sun, planets, and stars that go around Earth, but it is Earth and other planets that go around the sun. That is called Heliocentric Theory. Heliocentric Model. Dissatisfied with the messy epicycle model, Nicolaus Copernicus radically proposed that the model will become simple if we assume Sun is at the center and all planets including Earth go around it. Suppose Earth and Mars are on the two sides of the Sun, then Mars would be far and appear dim compared to when they are on the same side. Earth orbits around Sun in 365 days, whereas Mars takes 687 days. This implies at times Earth will overtake Mars. When the Earth is approaching and overtaking Mars, the Mars would appear to exhibit retrograde motion. In short, all the observed phenomenon could be explained in a simple way. However, how do we know that actually Sun is at the center or not? Galileo found that his observation of Venus gave the observational evidence to support the heliocentric theory. Galileo observed Venus in 1610 to 1611 with a telescope. To naked eye, Venus is just a gleaming bright spot. However, to a telescope, the shape of the planet can be seen. Galileo was startled to find, like Moon, Venus two exhibited phases. The shape varied from crescent to gibbous. Also, the size of the planet varied. When the planet was in gibbous phase, the size was small, and when it was thin crescent, the size was many folds higher. As the Venus went around the epicycle, as shown in the diagram, Venus would exhibit phases. Also, at times, the planet would be nearer, making the apparent size grow bigger, and at times far, making the apparent size smaller. Thus, the variation in brightness can also be explained. It became clear to Galileo that the geocentric epicycle model will not help in accounting for the observed phases of the Venus. Look at the given diagram. If the Venus was going around the Sun and its orbit is inside that of Earth, Venus would appear always near the Sun in the sky. It can never be seen in the midnight sky. 2. When it is near the Earth, it would be brighter and bigger compared to when it is on the other side of the Sun. Thirdly, only if the Venus is revolving around the Sun, it can exhibit gibbous phase and the size of the gibbous phase smaller than the crescent phase. If the Venus was revolving around the Earth, we can never see the gibbous phase of the Venus, and it would be seen only if it is orbiting the Sun. This clinching observational evidence proved that at the least, Venus orbited around the Sun. Further evidences collected by astronomers using telescope and other advanced modern instruments gave enough evidence that all planets revolve around the Sun. If Galileo were around today, he would surely be amazed at exploration of our solar system and beyond by ISRO, NASA, Russian space agencies and others. Now we can observe planets orbiting around other stars, proving that not only planets orbit around the Sun in the solar system, but all around the universe, such planetary system exists. Who knows, in some of there could be life, and in rare cases intelligent life like humans, wandering and exploring universe. Imagine a future time when such life meets us. How exciting and momentous it would be. Origin of the universe. You are a student who belongs to a particular class studying in 7th standard. In school, there might be many sections for 7th standard. Likewise, there are 6th standard class, 7th, 8th standard class, and so on. All of them together make the school. Likewise, a sun is a star with a planetary system. Billions of such stars constitute a system called as galaxy. The name of a galaxy is Milky Way. Like Milky Way, there are at least hundreds of billions of galaxies in the universe. How did all this come about? When we observed other galaxies, we found a strange behavior. All the galaxies were appearing to move away from us. Further and further they are, faster they appear to move. Cosmologists, scientists who study the structure and evolution of universe, that is cosmos, reason that this implies at one point of time in the past all matter was confined in a single point, and since then it has started to expand. That's what it's appeared to move. The event when the matter confined in a single point and began to expand is called Big Bang. This is considered as the origin of our universe as we know it. The Big Bang theory is the prevailing model of the evolution of the universe. Under this theory, space and time emerged together about 14 billion of years ago. At that time, the entire universe was inside a bubble that was thousands of times smaller than a pinhead. It was hotter and denser than anything we can imagine. Then it suddenly expanded. The present universe emerged. Time, space, and matter all began with the Big Bang. In a fraction of a second, the universe grew from smaller than a single atom to bigger than a galaxy. And it kept on growing at a fantastic rate. It is still expanding today. Over the next 3 minutes, the temperature dropped below 1 billion degrees Celsius. After 3 lakh years, the universe had cooled to about 3000 degrees. Atomic nuclei could finally capture electrons to form atoms. At that stage of the evolution of the universe, it was filled with clouds of hydrogen and helium gas. Giant clouds of hydrogen and helium were gradually drawn to the places where dark matter was most dense, forming the first galaxies, stars, and everything else seen today. We cannot see anything that happened during the first 3 lakh years of the universe. Scientists try to work it out from their knowledge of atomic particles and from computer models. The only direct evidence of the Big Bang itself is a faint glow in space called cosmosic microwave background. As billions of years passed, the dense area pulled in material because they had more gravity. Finally, about 100 million years after the Big Bang, the gas became hot and dense enough for the first stars to form. New stars were being born at a rate 10 times higher than in the present day. Large clusters of stars soon became the first galaxies. Hubble Space Telescope. The Hubble Space Telescope and powerful ground based telescopes are now beginning to find galaxies that were created about 1 billion years after the Big Bang. These small galaxies were much closer together than galaxies are today. Collisions were common. Like two flames moving towards each other, they merged into bigger galaxies. Our Milky Way galaxy came together in this way. Building blocks of universe. Universe is constituted of galaxies. Just as lot of houses in our locality constitute a village or a city, we have lot of things such as rooms, furnitures, etc. in our homes. Likewise, lot of stellar objects such as stars, planets, asteroids and meteors are the building blocks of our universe. Galaxies. A galaxy is a large collection of stars or cluster of stars and celestial bodies held together by gravitational attraction. There are about billions of galaxies in the universe. Most galaxies range from 1000 to 10,000 parsec in diameter. As we have different types of houses in a locality, the galaxies are also of different types. Types of galaxies. There are various types of galaxies such as spiral, elliptical, barred spiral, and irregular. Spiral galaxy. Spiral galaxies consist of a flat rotating disk containing stars, gas, and dust, and a central concentration of stars known as bulge. These are often surrounded by a much fainter halo of stars. Spiral galaxies are named by their spiral structure that extend from the center into the galactic disk. The spiral arms are site of ongoing star formation and are brighter than the surrounding disk because of the young hot stars that inhabit them. Elliptical Galaxy. An elliptical galaxy is a type of galaxy having an approximately ellipsoidal shape and a smooth image. Unlike flat spiral galaxies with organization and structure, elliptical galaxies are three dimensional without much structure, and the stars are in somewhat random orbits around the center. Interestingly, stars found inside the elliptical galaxies are, on an average, much older than stars found in spiral galaxies. Elliptical galaxies tend to be surrounded by a large number of globular clusters. Irregular Galaxy. An irregular galaxy is a galaxy that does not have a distinct regular shape, unlike a spiral or an elliptical galaxy. They are often chaotic in appearance, that means they are in disorder appearance, with neither a nuclear bulge nor any trace of spiral arm structure. About one fourth of the galaxies found so far are of this type. Cosmologists say that some irregular galaxies were once spiral or elliptical galaxies but were deformed by an uneven external gravitational force. Irregular galaxies may contain abundant amount of gas and dust. Barred spiral galaxy. A barred spiral galaxy is a spiral galaxy with a central bar-shaped structure composed of stars. Bars are found in approximately in two-thirds to one-third of all spiral galaxies. The Milky Way galaxy, where our own solar system is located, is classified as a bar spiral galaxy. Milky Way. The Milky Way is the galaxy in which our solar system is located. The diameter of Milky Way is over 1 lakh light years. The Milky Way includes stars smaller than our Sun as well as many other stars that are thousands times bigger than the Sun. It includes many other celestial bodies of gases, clouds of dust, dead stars, newly born stars, etc. It is also thought to contain at least 100 billion stars. The galaxy that is closest to our Milky Way is Andromeda. The descriptive Milky is derived from the appearance from Earth of the galaxy. A band of light seen in the night sky forms from stars that cannot be individually distinguished by the naked eye. In Indian mythology, this patch called as Akashaganga. From the Earth, the Milky Way appears as a band because its disc-shaped structure is viewed from within. Galileo Galilei first resolved the band of light into individual stars with his telescope in 1610. Until the early 1920s, most astronomers thought that the Milky Way contained all stars in the universe. Observation by Edwin Hubble showed that the Milky Way is just one of many galaxies. The Milky Way does not sit still, but is constantly rotating. Our solar system is located within the disk of the galaxy about 27,000 light years away from the center of the galaxy. The solar system travels at an average speed of 8,28,000 km per hour. Even at this rapid speed, the solar system would take about 230 million years to travel all the way around the Milky Way. When the solar system was in the same spot as it now, there were no humans, no Himalayan mountain, and the dinosaurs were roaming around the earth. Tucked inside the very center of the galaxy is a monstrous black hole, billions of times as massive as the Sun. Although black holes cannot be directly viewed, scientists can see their gravitational effects as they change and distort the paths of materials around it. Most galaxies, like our Milky Way, are thought to have a black hole in their heart. Constellation. A constellation is a recognizable pattern of stars in the night sky when viewed from the Earth. International Astronomical Union has classified 88 constellations to cover the entire celestial sphere. Many of the old constellations have Greek or Latin names and are often named after mythological character. Ursa Major, that is Saptarishi Mandalam, is a large constellation and it covers a large of the sky. The most striking feature of this constellation is a group of seven bright stars known as Big Dipper, that is, seven sages in Indian astronomy. Ursa Minor is Latin means the little bear. It lies in the northern sky. The pole star Polaris, that is Dhruva, lies within this constellation. The main group Little Dipper consists of seven stars and is quite similar to that found in Ursa Major. The Orion was a hunter in Greek mythology. The constellation comprises around 81 stars, out of which all but 10 are too faint to be seen with naked eye. Different constellations become visible in the sky at different times in the year. This happens due to the revolution of the Earth around the Sun. Unlike galaxy, constellations are mere optical appearance and not real objects. In galaxies, stars are bound by gravity and constitute a system. In a constellation, one star may be near and another very, very far, but because they are in the same direction, appear to be near to each other in the sky. Stars. A star is a luminous heavenly body that radiates energy. With naked eyes, we can see nearly 3,000 stars in the night sky and many more with the help of a telescope. The stars are remotely located and appears as tiny dots of light. Their light travels long distance to reach us. The atmosphere disturbances do not allow light to reach us in a straight line path. Because of this, the stars appear to twinkle. The Sun is the nearest star to the Earth. The next nearest star is Alpha Centauri. Satellites. An object that revolves around a planet in a stable and consistent orbit is called a satellite. Satellite can be classified into two categories: natural and artificial. Natural satellites. All natural objects revolving around a planet are natural satellites. They are also called moons. Most moons are spherical, the ones that are not usually asteroids or meteors that were captured by the strong gravity of a planet. All planets except Mercury and Venus in our solar system have moons. Earth has only one moon, whereas planets like Jupiter and Saturn have more than 60 moons. Artificial satellite. Artificial satellite are man-made object placed in an orbit to rotate around a planet, usually the Earth. The world's first artificial satellite launched was Sputnik 1 by Russia. Aryabhatta was the first satellite launched by India. These satellites are used in television and radio transmission, studying agriculture yield, locating mineral resources, weather forecasting, locate different places on Earth. ISRO. The Indian Space Research Organization ISRO is the space agency of the Government of India headquartered in the city of Bangalore. Its vision is to harness space technology for national development while pursuing space science research and planetary exploration. Indian National Committee for Space Research established in 1962 by the scientist Vikram Sarabhai. The establishment of ISRO thus institutionalized space activities in India. It is managed by the Department of Space, which reports to the Prime Minister of India. ISRO built India's first satellite, Aryabhatta, which was launched by the Soviet Union on 19 April 1975. It was named after the Indian astronomer Aryabhatta. In 1980, Rohini became the first satellite to be placed in orbit by an Indian-made launch vehicle SLV-3. ISRO subsequently developed two other rockets, the Polar Satellite Launch Vehicle PSLV for launching satellites into polar orbits and the Geosynchronized Satellite Launch Vehicle GSLV for placing satellite into geostationary orbits. These rockets have launched numerous communication satellites and Earth observation satellites. ISRO sent a lunar orbiter Chandrayaan-1 on 22 October 2008 and a Mars orbiter mission on 5 November 2013, which entered Mars orbit on 24 September 2014, making India the first nation to succeed on its first attempt to Mars, and ISRO the fourth space agency in the world as well as the first space agency in Asia to reach Mars orbit. On 18 June 2016, ISRO set a record with the launch of 20 satellites in a single payload. On 15 February 2017, ISRO launched 104 satellites in a single rocket, PSLV C-37, and created a world record. ISRO launched its heaviest rocket, Geosynchronized Satellite Launch Vehicle Mark III, on 5 June 2017 and placed a communication satellite GSAT-19 in orbit. With this launch, ISRO became capable of launching 410 heavy satellites. ISRO launched Chandrayaan-2 on July 22, 2019 in Geosynchronized Satellite Launch Vehicle. It entered the Moon's orbit on August 20, 2019 and its lander landed on the Moon on September 7.